Hello, let's render some textures in OpenGL. First of all, we start with the program linked in the description. It displays a triangle. I have a video on how to create this program if you want to look at it. So let's jump into the code and do a fast recap. We make a initialization of the OpenGL utility library. We tell it which display mode we want, and we want double buffering, and we want RGB mode. We tell it to create a window that's called my window. We set the size for the window. We tell it which function to call when it needs to redisplay. In other words, draw the window. And we call this main loop. Here we got the function for displaying something in the window. First we clear the GL color buffer bit, which tells the system to clear the color buffer, the buffer that contains colors in the memory. We start with saying that we will create a polygon. We have 3 vertices for that polygon. So if remember, that's the vertex, that's the vertex, and that's the vertex. So we have 3 of those. Then we call GL end. We flush those commands down to the graphics system, and we call a swap buffer, so it should swap the memory buffer for what's displaying on the screen. And I want to change this. I want to change it from a polygon to a quad. Or for some reason, quads in this is called quads with an S. Of course, polygon is not. So not polygons. Could be a bit confusing, and it is a bit confusing. I was talking about the coordinate system in the other videos at this 0, 0 in the middle. And then I think I said -1, 1 in the top corner here and 1, 1 bottom here. That's wrong, apparently. Starts with -1, 1 in this corner and 1, 1 here, I think now. It really doesn't matter. You just need to flip the image when you're done, or what you display on the image. So either way works kind of good. Let's hope that's correct now. So now I need a quad, and let's try to follow this. Need to specify the corner up there. That's -1, 1, and then we need to go to that corner. It's 1, 1, and then go down there, and that's 1, -1, and that's -1, -1, and let's see if we have a quad. And I think we have a quad. It's a little bit hard to see, to be honest, but I do think we have a quad. That's fine. Now let's display or set it up to display textures. So we need an init method if we do not want to mix in setup information here. So let's just call the method that sets up the texture instead. I think that probably will be looking nicer. So the first we need to do is tell OpenGL that we're going to use textures. OpenGL is a state machine. So we need to flip a boolean somewhere in that system and tell it, hey, we're going to actually use textures. So let's enable that. Then we need to tell it to generate a space, most likely in the GPU, for our text here, and we want to generate 1 of them. And then we need to provide a texture ID. It's going to send back a texture ID to us. And those texture IDs are just numbers and just ints. So there we have our texture ID. After we generated the texture ID, we need to tell the state machine, hey, I want to actually use this texture. I want to work with it. So we need to, it's called binding. So we bind the texture. So we tell the system that we're working with a texture that's a 2D texture. There's a 1D texture also. I'm not sure if there is a 3D texture or not. So we bind the texture. And after that, we're going to set a few parameters on the texture, else it won't render. So this is required. See if I can just copy paste up this. We need 4 of this. So they all start with GL texture. All enum seems to start with that when it comes to texture. So we have wrap S, we got wrap T, and if you have a texture, so this is your texture. Normally, if you have a rectangle like this, you call it width and height. Well, on texture you don't do that. You call them S and T for whatever reason. Anyhow, so for the parameter for textures and the texture wrap on the S, which means that if this is 0 and this is 1 and we want to access 2 over here, then that one should wrap around and we will actually reading back at 1 again. So we're going to set that to GL repeat. And you can also clamp it, which means if you access 2, it's going to clamp back to 1, which seem at first like what you want, but in reality you probably just want it to repeating around. And then we need to set if we scale the texture, and if we want the texture that's smaller than what's provided, we need to tell it how to scale that. And if we want the texture that's higher than provider, bigger than provider, we need to tell it how to scale that. So if you have a texture, a huge texture here, I'm actually going to use an even smaller texture for the first test, and I have a little bit bigger later. And each of these are a pixel. So this is a pixel, this is another pixel. If you want a smaller texture than 4x4 rendering on your screen, so you want a 2x2, then it becomes the question, if you want this corner up here, which color of these should you pick and render? And that's what this line determines. And it says linear here, which means that it will pick a few, I think it's all 4 of these, around where I want my coordinate and mix those colors together. So if I want a smaller texture than provided, then we need to have a linear there. Else, if I picked the nearest, that's on when we want to have a bigger texture than's provided. In this case, it's going to pick the nearest. It's going to pick one. If you want the air really, we're going to pick this full picture, the value of that one. One have to think about it a bit before it makes sense, but it do make sense. So we need to set that. After that, we need to load our texture, the data to actually display. And this one is tricky. So let's start with creating some data for it. And I think we create a texture. Let's see here. Just create a texture with 4 pixels on it. So one color there, one color there, one color there, and one color there. Just to see if it works. So let's have No, now it becomes problematic. What pattern should we pick here? So let's do like this. I changed my mind. It's allowed. There we go. So we're going to provide some bytes here. That's R, G, B, and alpha channel transparencies. So we're going to have R, so red, and the green pixel. So 1 here is red, 3 is green, and 2 and 4 is just a dimmer variant of the red and of the green. So let's fill in this one so it actually fits in the data type. That's the char up there. There we go. And then we needed to load the data. Then we have a load level, meaning if the texture is very far away, maybe we want to use another texture than actually relying on these calculations. So we can say on a load level we'll choose another texture, but we won't do that. Then we need to tell what format we stored our data in, and we stored it in RGBA. And we had the size of 2 times 2. And we have a 0. Let me think if I can remember why we have a 0. I know we do. Something about format. It is something about format. So level height. Oh, border. I forgot about the border. So when rendering textures, we can have a border around it. So we don't get the repeat. So when we pick something that's outside, we're actually going to pick the border color. I think that's how it works. I probably never use the border, so I always set it to 0. But let's remove that documentation there, because who wants to read that? Try from memory, and if it fails, then we go to documentation. And that's the display format, and that's the format of the data we send in, if they can be different. And what we're going to send in, we're going to send in an unsigned byte. We had an unsigned char, but there's no unsigned char in OpenGL, but it's an unsigned byte. That's the same. So now we have told where the memory is for the texture. We have told what format it is in. Both of those are for format. We told how big the texture is, how we want it to be displayed. Let's see now. We generate the texture, we bind it. And after we're done, we should delete the texture. Is it called del or is it called delete? I think it's delete. Now let's try running this. Pointer int texture ID. Pointer target is passing to in different signness. Should it be an unsigned? GL texture wrap. undeclared. Oh, warp. Yeah, I was like, there's something wrong here. Repeat. Textures, of course. There's more than, could be more than one. And so far we got nothing, so something is wrong. Let's see if we can figure out what's wrong. We enable the texture, we generate it, we bind it, we set all the parameters. We'll actually try to set the parameters before we create it. Ah, wasn't that. Remove the color. Oh, yeah, I'm blind. Maybe we should actually tell the system coordinates of our texture. When it tries to render it, it probably needs to know what part of the texture it should render. So each vertex needs to be associated with a coordinate of the texture. Just going through the different corners of the texture there. There we go. Okay, still didn't work. So we have set the text coordinate. I need to have my texture bound before setting them. So I need to create a texture, bind the texture, and then set my parameters, download the data. I did it in the wrong order. So now we got a texture. And my colors were red, and nothing on G and B, and alpha is full. And then we had the dark red, and the same with green. So that seems to be working. And just to make it a little bit more fun, let's actually rotate it. Then we have the degrees, how much we will rotate it. So rotate it 45. And then we have the axis we want to rotate it around. It's not called 3F, is it called just F? And there we go. And each time it updates the window, when I click in here, it rotates another 45 degrees. So let's do going to post redisplay. And let's not do this in any loop without stopping anything. So let's do it every 100 milliseconds or 100k picoseconds, I guess. And you shouldn't have a sleep in the render function. I mean, come on, but this is just to demonstrate how a texture works. So, and that went a little bit fast. Rotate it a bit slower. And there we go. It looks wonderful. Now, I mean, this is amazing and all of that, but that's not what you've been looking for this video. You want to render a texture, and when texture, you're thinking an image, right? So we need an image. So download GIMP and load in whatever picture you want. Make sure it's 2 times 2, so 128, 256 or 512 or something like that. Load your image, file, export as, select the name, and look at my extension here, .c. You want to replace it? Yes. Yeah, I already have it. And when you get this dialog for the first time, this is clicked in, use glib types. Unclick that, so we won't use that. And let's call it pixel data. Was that the thing? No. Image. Image sounds good. And just save that one. And then we're just going to include image 256.c. And I have done this before, so I have a tab here. So that's my picture. And you see it's a struct that contains the width, height, bytes per pixel, and pixel data. I happen to call what we were using before pixel data, just to make it extremely simple. So we need to modify the command that reads in the pixel data, so it has all the correct width and size. And bytes per pixel I'm going to ignore, because I've checked that it saves as an RGBA that has a ×4 there, so it's kind of obvious that this is that. And if you look close here, it actually specifies that it's 4 bytes per pixel. So I'm just going to ignore that. That's the same that we've been using before. So let's see now if I did it correctly. Image width, image height, image data. And we include the image, which means we include this code directly in to this source. And there we go, a texture quad in OpenGL. And the source code will be a link in the description, like always. Have a great day.